Hi, I'd like to talk with you today about the continuity of piecewise-defined functions. Piecewise-defined functions are split into different branches depending on where the input value is. So here we're going to talk about a generic function f that's piecewise-defined. It's split into two pieces. You can have as many as you want, but we're just thinking about this one having two pieces. It's got a left piece and a right piece. And the transition between those two pieces lives at some critical x value x sub c. I think the right way to think about this is in terms of a drawing of the picture. So I'm going to start by putting down a set of axes. So I'm going to go like that, say. Got some axes. And let's suppose that to the left, my function looks like that. And then to the right, my function looks like that. I'm going to put an open hole, because there's no or equal to right here, on the left branch. And on the right branch, I've got a filled in hole like that. This function keeps going on forever. Good graph always has labeled axes. So here's some axes. That's the x and the y axis. The place where this transition is, where it jumps from one branch to the other, I'm calling x sub c in this generic setup right here. So over here, we've got f sub left, and over here I have f sub right. I could have gone like f minus and f plus. That would have been okay, but we're to the left of x sub c and the right of x sub c as far as this goes. So I want you to observe that this function that I've drawn is discontinuous. This function's discontinuous. This function's discontinuous, and it has which kind of discontinuity? I've already used the word once. Is it removable? Can we just fill in the hole? No, there's no way I can just fill in the hole and achieve a continuity of this thing so that I could just draw it with one marker stroke. In fact, this is a jump discontinuity, and because there's a jump, if a grasshopper was walking along here, in order to get over here, it'd have to jump from one branch to the other. So there's a jump discontinuity in this function f, this piecewise-defined function f. And what I want to think about with you is there a way that I could change f and make it continuous? So what do I need to change in order to make f continuous? What do I change to make f continuous? Where I like writing CTS, it's way easier than writing the whole word continuous. Okay. So what do I change to make f continuous? Well, there's a gap right here, and so I could try to eliminate the gap. I could shift the left or the right piece up or down. So I've got a couple of options for how to do it. Option one is like shift f sub right. We could also shift f sub left. We're going to shift it vertically. So I'm going to try to eliminate this gap right here. So I could translate this down and make it so that now I've got my function down below, right? And so this vertical distance between the two branches, between the pre-shift and the post-shift one, is constant. There's a constant vertical distance right here. So if I can find out the distance between these 2 points and then just shift f sub right by that distance, then I can make the function continuous. So the way that I'm going to model that is by going by a constant value a. So I'm going to modify my function, and I'm going to be like, let's go f sub right plus a if x is less than x sub c. How much should I shift it? Well, I should shift that I should really shift it down by a, where this distance right here is how far I need to shift the right branch to line up with the left one, so that it's just like, oh, and now I'm just on this one, and like I could just draw it with one stroke, and that's okay. Okay. So that distance right there is the difference between these two function values. However, I can't evaluate the left branch at x sub c because there's a hole there. So this gap right here, that gap, a, is equal to the difference between these two things. And I'm going to do it as the difference between f sub right at x sub c minus, it's the gap here, so I'm going to subtract, minus the limit as x approaches x sub c of f sub left of x. So if I can just figure out what these two values here are, I take the difference, and that's how much I'm going to shift my function by. Okay, so that's option 1. So we're going to figure out what's the height of the function at those two places. I'm going to take the difference, and then I'm going to shift, and then I should approach the same place from both branches. On the other hand, I could change the place where the jump happens if the two functions, if I were to make f sub left and f sub right go forever, if they intersect. So option 2 is to go and figure out where do they cross and change x sub c to be that. So I'm going to change x sub c to be a crossing. A place where f sub left and f sub right cross. So in order for this to work, the two functions, f sub left and f sub right, without domain restrictions, the domain restrictions right here, have to be able to cross. So if I were to keep drawing these functions, they would intersect at those two places. Let's say, if they're parabolas, let's say that happens. So instead of x sub c being where there's a gap right here, I could be like, oh, how about I use this point right here? Let's call that x sub d, or this value right here, x sub b. So we're going to change these two places. And we're going to change that one place. But we're going to change that value so that the split happens at a different place. Forgot to put my equals. Okay? So to do option 2, the method looks like solve f sub left of x equals f sub right of x. And now I think I should modify what I wrote right here, because it's not like generic x, this is true. It's a special x called xb or xd. I'm not certain that it exists because not every two functions intersect like this. So just writing this down doesn't mean it exists. This is a asking of a question. So how about I go x sub b right there, and I write a question mark above that to be like, do they equal each other ever? If so, let's find it. I want to find this place. And then I'm going to modify this to be x sub b instead. That special place where these two functions come together. Because then there's no gap, and I don't need to adjust for the a. Okay? So there are, broadly speaking, like 2 big types of problems that we ask in the world of continuity in the Calculus 1 class that are make the function continuous. And one of them is about shifting them, and the other one is about finding their intersection points. Yeah, both of them involve some equality and then solving it in order to solve the problem. Okay, so I hope that's enough to get you off the ground for the two types of continuity problems that you are encountering as far as piecewise defined functions and making them continuous. Thank you very much for watching, and I hope you have a lovely day.